Welcome again, ladies and gentlemen, climate enthusiasts, AI enthusiasts. This is the keynote round of the Predictive Analytics World Climate this afternoon, and I'm very happy to first introduce you to Eugene Kirpichov. Eugene is based in California, so if he sleeps away during the presentation, please bear in mind it's very early at his place. Eugene spent quite some time as a software engineer for a large search engine company in California that we all know. He also was part of Google AI Cloud Platform, and then finally stepped out in August 2020 to focus on his activities on climate change. So he is the founder of Work on Climate, and evenly important for this organization today is that he is the initiator of the Predictive Analytics World Climate in the US. So a warm welcome to Eugene. Looking forward to your keynote. The floor is yours.
Yeah, thank you so much. Hi, everybody. Indeed, I'm Eugene, and everything just said about me is correct. So yeah, today I'm here to tell you basically why now is a really good time to switch careers into working on climate and to do the same thing I did, which is quit your big tech job if you have to. So yeah, first a little bit about me. Indeed, I spent the last 7 or 8 years at Google, like building different boxes connected by lines like MapReduce, Cloud Dataflow, and Apache Beam, and various neural network infrastructure at Google AI. And then in summer 2020, I hopped out to find my place in climate, and I will start by explaining why. Like, what was the sense of urgency for me? There will be just a little bit of doom and gloom here. I don't believe in doom and gloom as a main motivator, but I think it is necessary to have sort of a bulletproof picture in your head of exactly why you're doing this in order to be able to do it. But the rest of the presentation will be much more bright. So I like to think about this in sort of 3 buckets, like how bad, how sure, and how come. How bad is it? How sure are we that it's really this bad? And how could it possibly happen? As for how bad, what is the sense of urgency here? I find that the most convincing arguments for me first are these. So, the statement that we're moving towards plus a few degrees per se isn't that threatening until you remember that, for example, 4 degrees ago, Boston was under a kilometer of ice, and other cities in North America and Canada were also under a huge ice sheet. So this gives a sense of how much difference the temperature actually makes, and temperature is actually the wrong measure to think about here. And a couple of other numbers that really resonate with me are that according to current, I believe, average case projections, we're headed towards hundreds of millions of climate refugees fleeing areas that become uninhabitable by 2050. And the economic models, some of the economic models are projecting something like 18% global GDP loss, which is on the same order of magnitude as wiping out the entire industry. And the kicker is that these projections are actually optimistic. They are ignoring some of the climate feedback loops, and they're ignoring social disruption and so on. So yeah, these are the numbers that sort of paint to me the picture we really have to avoid. As for how sure we are about all of this, I find a couple of arguments here really convincing. So one of the tipping points for me was realizing that the reports published by the Intergovernmental Panel on Climate Change are actually enjoying the most consensus I'm aware of any document that humanity publishes. So the summary for policymakers is approved unanimously, sentence by sentence, by all participating countries, including countries that are really not known for being climate champions, like America, Russia, or Saudi Arabia. And the other argument, it's always a good idea to look what the money says. And the money says that we need to tackle this problem. For example, the central banks of England, France, and Netherlands, and even the United States Federal Reserve are conducting or mandating or planning stress tests of their portfolios, so whether the companies are going to survive the climate damages and whether the companies are going to continue to be viable in a post-carbon economy. So these are, again, institutions not known for being climate champions. If they are saying that it's time to tackle this, that means that the GDP really is at stake, like the economy is at stake and our livelihood is really at stake. And finally, like this all won't really make sense until you sort of have an idea of the mechanism by which so much damage can be caused. And for this, I think it's important to remember that the input into the climate system is not the temperature. Temperature is the output. But CO2 concentration is more of an input. And we have increased CO2 concentration not slightly, but by like 1.5x. And this picture here reminds you what happens if you, for example, increase the input voltage on the circuit by 1.5x. And as for how come humans could do such a big change, we're kind of a blip on the Earth. Well, turns out we're not. So the analogy I find most convincing here is that the yearly emissions we have from burning fossil fuels and other related processes are the same as would be if we burned every single tree in the United States to the ground. Like imagine an America-sized wildfire. I guess nobody in the right mind would doubt that that would affect the planet's climate. Well, to the same extent, it is affected by burning fossil fuels. So enough doom and gloom. Let's get to the hopeful part. So with all of this in mind, like, of course, I basically couldn't handle anymore like not working on having my part in the solutions here. And I thought that I was going to be, a hero, like jumping into a tiny part of the human economic activity that's working on saving the planet. There are the big industries with the real money and real resources and real talent. And then there is sort of to the side, like the little bit, the budding small industry of saving the planet. And with that picture in mind, I guess, which maybe some people in the audience also have, you could try making some guesses as to what percentage of VC investment goes to climate, like how many unicorns are there, if any? How does its growth rate compare, for example, to the growth rate of something familiar to all of us, such as AI? You can make some guesses and remember these guesses in a couple of slides. So turns out, though, actually, that I was really, really wrong. And I realized this quickly after leaving and talking to people in climate. Turns out that climate tech is hiding in plain sight because it's not to the side. It's embedded in every single big industry. And again, like nobody in the right mind would say that decarbonizing the energy grid is a small opportunity, or that electric vehicles are a small opportunity, or that decarbonizing manufacturing is a small opportunity. And all these industries are taking this really seriously for a number of reasons, one of which is that investors and banks are starting to show them the door if they don't have net zero targets. But there are other reasons. For example, there is just an incredible amount of headroom in efficiency. So a lot of these industries are just plain really, really inefficient. And now that there's pressure from the climate side to fix that, they're starting to realize that and fix it. But there are also a number of just climate-specific levers. But basically, the point is that the climate ecosystem is shaped differently than what many people think it is. And because of that, it is also much, much, much bigger than most people think it is. These numbers were a complete shock to me when I learned them. They come from a report called State of Climate Tech 2020 by one of the big four consulting firms, PricewaterhouseCoopers, again, not known for being a climate-focused organization. So yeah, climate tech is already 6% of all venture investment. There are 40 plus companies valued at over $1 billion in this. And perhaps most shockingly, since 2013, it's grown 37x, which is 3 times more than AI. And basically, this is our little secret that I hope you will spill to everybody you know, because currently nobody who's not already working in climate seems to know this. I've met even heads of climate employee groups at big tech companies who didn't know this. But everybody in climate knows this, so quite a bit of an awareness divide here. So even if you know all this, you're also still going to face a lot of fears. That's natural. And I think the analogy of the 4 horsemen of apocalypse is apt here. So we're going to face 4 fears that I found most common among people considering switching into climate. The fear that it probably doesn't pay, it's probably all nonprofits, activism, and academia. The fear that it's probably low tech and doesn't really need your sophisticated ML skills. The fear that the area you pick is going to be too niche and won't make much of a dent in climate. And the final, most insidious and I guess most dangerous fear that fearing that you just won't fit in. That like there's climate people and there's us tech people, and that these are different worlds. And I'm going to dispel these fears one by one. The fear that it doesn't pay is unjustified. Climate startups are normal commercial organizations. They pay the same as other startups. I mean, it's not as much as you can get at Facebook or at Google, but it is as much as you can get at another startup. Lots of people are comfortable working for startups. And if you're comfortable working at a startup, you should be comfortable working at a climate startup because it's going to pay the same. It's the same salary, the same equity expectations, the same everything. Second fear that it's probably low tech or doesn't need ML is unjustified as well. So you can think of the sort of technical side of these organizations as a pillar of 3 blocks: their tech stack, their machine learning expertise, and their domain expertise. And as for the technical stack, it's quite ordinary. It's the same as other startups. They also don't want to reinvent the wheel, but they also want to use the best technology available. So for example, a startup that I worked at for a bit called Pachama, they use a regular stack. They run on Google Cloud, Kubernetes. They use Google's data processing stack. They use Python, Postgres, PyTorch, and whatnot. The ML expertise, though, that climate startups working with machine learning use is really interesting and unique. They're not solving over and over the same problems that big tech companies are solving. Like they're not just, continually squeezing out fractions of a percent on what post to recommend to you in the feed or like what ad to show. They are solving real world problems, and real world problems are messy and have lots of constraints, and you sometimes can't afford to be wrong. So these problems are really hard and really unique to whatever industry is being decarbonized, and they're really interesting. For example, there's this company called AMP Robotics. They're building robots that sort the waste stream, which turns out to be like a really lucrative problem. This is also a problem where if you squeeze out a couple fractions of a percent, you can sell the result for several times more. So this is hard real-time computer vision and robotics on what is literally piles of trash. It's pretty bad compared to the normal image classification tasks, and really interesting. Others also use really sophisticated reinforcement learning for demand planning for grocery stores, or like they accelerate supercomputer physics models by several orders of magnitude. And generally speaking, machine learning has a huge role to play in climate because machine learning is really good at improving the efficiency of systems or at modeling things. And both of these turn out to be really important for climate solutions. As I mentioned, a lot of the world's industry is incredibly inefficient just because nobody bothered, because we could just keep pumping more and more money into inefficient stuff. And there's a lot of room for improvement there, and machine learning works great for that. And the final thing, though, that I think is really appealing as an argument for why join this industry is that climate tech companies tend to have truly world-class domain expertise in the industry that they're working in. For example, a company called One Concern, which is working on disaster modeling, which is really important for being prepared for the disasters to come. Their head of disaster modeling is the head of disaster management for the United States, somebody who used to be in that role. Or like the company called Indigo Agriculture, one of the unicorns, by the way, valued at over $1 billion. One of their co-founders is the co-founder of Moderna, so you can imagine how good they might be at biochemistry, for example. So yeah, the concern that climate tech is slow tech or doesn't need ML is unjustified. The next fear is also pretty scary. Like what if you pick the wrong area to work on? What if it turns out to have minor impact? But I find that in the end, this is a problem of just fear of missing out and a problem of ambiguity. So until you know enough about climate, sort of all of these areas seem niche. For example, like I talked to this company called Afresh, which work on food waste, and I was like, I don't know, food waste. It seems kind of niche. But turns out that food waste can affect something like 8 or 12% of emissions, which is an incredible number. So basically the way to address this fear is simply when something looks niche, just go learn about it. Just spend a couple hours watching YouTube videos, educating yourself about this domain, prepare some questions for the company and talk to them. And usually by the time you do that, you won't feel that it's so niche anymore. But if you still do, then don't settle. Keep looking for other companies. So yeah, basically what I'm saying is that you won't have to settle for something that looks niche. I'm pretty certain that you will find something that is in alignment with your philosophy of impact. And the final fear, like the really bad one, is like what if it's just not for people like me? What if people who work in big tech and people who work in climate are very different people? And to address this, I would like to show you this collection of logos of companies that presented at PAW Climate for North America, which I was chairing a couple of weeks ago. And on the next diagram, I'm going to show you how many of these have people from big tech as founders, advisors, or employees. Again, you can make a short guess here and imagine like how many that might be. Well, ready? Yeah, this is how many. The majority of them, actually. The majority of them have people from big tech. A good number of companies that I didn't list here have founders coming from big tech. Generally, the exodus has started. I meet people from big tech who are quitting into climate or who are actively looking for that, like pretty much every day or at least every week. So yeah, if it's cool enough for these people, there's a good chance that it's cool enough for a lot of people too. I also want to acknowledge that some people have factors that prevent them from changing jobs. And in that case, if you have to or want to stay at your company, like if you just really like it, or for some reason you can't move now, I think that a good way to think about it is think about it like COVID. We've all seen that pretty much all of the major companies have mobilized themselves in some way to fight COVID. Google Maps is showing you where you can get a vaccine. Like all the companies are fighting COVID disinformation, all the companies that have to do something with disseminating information, and so on. So here are a few examples of companies that are already doing something, using their company's power in some way to help climate, and some examples of companies that could do this but aren't always doing so. So Facebook, for example, they have, I believe, a division focused on combating climate disinformation, a pretty good way to harness their enormous power to make a dent here. Autodesk, which is making automated design tools, they have their division focused on building tools for architects. They're working on making it easier to design energy efficient buildings. The building industry doesn't always put this at the forefront. So when a tool put this at the forefront, that results in it being treated more seriously, and in more buildings being designed in an energy efficient way, which is actually a really good way to reduce emissions. Companies like Salesforce, which work on creating enterprise software, supply chain software, client relationship software, and so on. All of these companies now have products focused on measuring emissions, tracing emissions through the supply chain, and planning reductions. And financial institutions like Barclays, many of them have tools for computing the climate risks of their portfolio. Companies like LinkedIn and Glassdoor could, highlight climate jobs before job seekers. Real estate apps could highlight flood and wildfire risk, and so on. So yeah, for many companies, there is a way to use the company's power towards climate, even if the company's emissions are low and there's not much to reduce, and even if the company itself doesn't have much to do with climate. Treat it like it's COVID. So a number of resources, you can consult this afterwards, but I want to basically give you one call to action. I'm hoping that in this presentation I have convinced you that climate tech is an incredibly active field that really needs you and where your skills will find a great use. And this is information that's new to most people. So my call to action is to go and share this with your coworkers and friends. Become the person in your crowd who has something actionable and positive to say about climate. Don't just share doom and gloom. Share this. Share that actually all of your tech friends, there is a room for their skills in climate. For example, like at Google, we had a tradition that when somebody goes to a conference, they do a debrief before their team. maybe do a debrief before your team on this topic, like take a look at the ecosystem from your point of view and share what you find. I mentioned this in one-on-one meetings and so on. And finally, indeed, I am also a co-founder of this community called workonclimate.org, which is focused entirely on helping people use their skills as professionals in climate. And we have a number of programs there. One of the programs is that you can talk to a climate expert for free. We have something like 12 people offering their time for free, just as bookable calendar links. And I found that talking to somebody who knows their stuff around this is also a great way to get hyped up and motivated. So I suggest, go there and book time with somebody and just chat to them about how your particular skills can fit in climate. There are some people that are specializing in AI particularly as well, and in helping people in AI switch into climate. So that's it for now. Thank you so much.
Thank you, Eugene, for this impressive keynote and your insights and call to action, honestly, at the end. Very impressive. We will have a Q&A at the end. And before we go there, I like to draw your attention to our second keynote. So I like to very much welcome Nicolas Milojevic-Dupont. Nicolas, you are a PhD candidate at the quite renowned, at least in our area, Mercator Research Institute for Global Commons and Climate Change, MCC, in Berlin, in conjunction with the Technical University of Berlin, and you are a founding member of Climate Change AI. Thank you very much for your contribution already at this point. The floor is yours.
Thank you so much. Thank you so much for the invitation and for organizing this this great conference. Thank you so much also, Eugene, for the very engaging presentation. That's great to present after this and try to bring my 2 cents essentially on what's happening on the academic side. So essentially, I'm going to try to complement the previous keynote by giving some what are the ideas of new applications that and proof of concept that are coming from the academic side, and essentially what are all these nice ideas that are just asking to be deployed on the ground, and there are a bunch of great opportunity for industry. Climate change, it is happening, and this is going to happen very soon with increasingly severe effects. So we need to prepare for that. We need to mitigate climate change. So in the European Union, they are increasingly, the awareness is increasingly here. And so the European Union now has 55% reduction target in 2030 compared to 1990. That's a lot, and that's very soon. So it is not in the paper, and now it needs to be implemented. And AI and tech has a key role to play here in the mix of different solutions. So here on the other side, we have artificial intelligence that we are hoping can participate to mitigating and adapting to climate change. Also, no need for me to explain what is artificial intelligence, but it has key strength that it enables us to perform tasks at scale, optimize complex systems, generate data. So all things that are actually very important for working in climate. Also, always keeping in mind the limitation. If we have bad data, it's going to be difficult to do something good. Biases are going to stay here, and any time of patterns are also persistent and important. So from this starting point, I was part of a group of researchers from machine learning and climate spheres that wanted to have a look at what's existing in academia in terms of existing literature. So we wrote this large paper where we try to make an assessment of the different application areas that were existing. And so I'm going to go through a few of the recurring themes that that we observed in this paper. So, and yeah, these different teams are as many applications area where there are various things that can be impactful for climate adaptation and mitigation, and yeah, where essentially there are a lot of industry opportunities here. So first one is to gather information. So for example, on GHG emission, on deforestation and infrastructure. So essentially key information that's lacking to develop climate strategies. So one example here is, for example, to retrofit buildings. So why? Because the building sector is generating a very large carbon footprint, can be up to a third of the energy use and energy emission in certain areas. So big drivers here, for example, heating and cooling buildings. And for example, cooling is going to become more and more important in the future with increasing temperatures. So here there's a key application of machine learning, which is to predict different information, for example, building attribute that can be used for energy modeling. Here you can, the different kind of AI that can be relevant is in general supervised learning. So that can be very standard. All random forests do the job on simpler feature engineering in certain case, but there are also new, much more fancy computer vision tools. So, and yeah, with very basic map data, as I have shown in a paper that's cited here, you can generate information that's very useful and that's currently lacking, for example, building heights. Another key theme is forecasting, and that's very important for many sectors relevant to climate change, so renewable energy, transportation demand, also extreme event, given that they are increasing. So an example here is doing solar PV nowcasting. Why? Because the future climate, but at a very short scale. So that's why nowcasting. So in the coming minutes and hours are very important for PV generation. And if given the fact that the grid needs to be balanced, if you don't have if you are not sure that you'll be able to produce some power, then you need to have backup generation, which is usually which usually has a much higher carbon intensity. So it can be, for example, oil or gas that is used there. And so if you are not able to predict properly what is going to be the future PV generation that you will do in the next hour, then you are forced to switch on this backup generation and then actually use CO2, like generate CO2 emission that you actually don't need. So here a key application is to forecast what's going to be the power production to help manage the grid. And here AI is actually very good to do like through the different time series algorithm that can learn patterns from historical data to do actually more and more accurate predictions. Third theme is to improve the operational efficiency, for example, of buildings, but also freight, food waste. So here HVAC is a key example. So I said that the building sector is a key contributor to climate change, but actually HVAC within the building accounts for usually more than 50% of the energy used, and there are very big efficiency gaps here that could be fixed with more efficient operation systems that understand better the thermodynamics of buildings, the usage pattern, and different constraints. So yeah, that's actually a field where there are a lot of control applications, so application of machine learning for control, so to generate automatic control strategies, for example, with reinforcement learning, that learn how to optimize the operation of a building, given the different specificities of this building. Fourth theme that I want to put forward is predictive maintenance. A big one is gas leaks for big pipelines, where you can have, for example, methane leaks that are a very big problem, or resilient infrastructure. Here, the example that I have on the slide is on the maintenance of rail system. So, yeah, railways are really critical to decarbonize both passenger and freight transportation, as opposed to a key current focus to individual car ownership and not necessarily ways of transporting freights, such as too big use of trucks. So yeah, there are also many complex problems, and here the different applications of machine learning can come around how to do predictive maintenance to increase the efficiency and the cost competitiveness of these complex rail networks that are also large and difficult to manage. So here, AI can be used to analyze sensor data and predict at scale present or future anomalies that would be otherwise quite difficult to maintain just with human oversight. And then, a fifth recurring theme is how to do scientific experimentation, for example, for batteries or for clean energy materials in cases where it's actually very costly and very difficult to do experimentation, like an actual physical experimentation. So it can be very helpful for accelerating research and development. For example, for electric storage technologies, which, as you know, are a key building block for many decarbonization strategies, given, for example, the intermittent nature of renewable energy, and also the different different devices or systems, or, for example, vehicles that require some storage of electricity. So research and development in the battery industry is actually costly and difficult. So there are different opportunities to do simulations that can be speeded up with machine learning, for example. So here the role of AI is to guide experimentation of newer generation of batteries at lower cost and faster. So so those were the six recurring themes, main recurring themes that we found through this paper. So you see that it's very diverse, and so to echo Eugene's point on the fact that, oh, maybe working on climate is not for me, or it's actually so diverse, the pool of different themes that you can work on, that there's a high likelihood that if you search through all these different options, there's going to be one that you find interesting. I just wanted to finish this presentation by giving like a little bit of a broader considerations beyond this specific application that you can work with. So one key ingredient to think about when applying climate change, machine learning to climate change, is to put machine learning or AI in the context of the application. So one important aspect is that there are many climate strategies that actually do not require AI, and so it's one of the worst things. It would be to try to put AI everywhere, as opposed to trying to figure out where AI is applicable and where it can actually make a key impact. And I've shown that these cases definitely exist. And when these cases exist, one thing also to keep in mind is that AI is only one part of the strategy, and that the AI system needs to be embedded in a broader understanding of what are the other pieces that it's going to interact with. So, for example, this specific tool is going to be used by users, and it's important to understand users who interact with this tool, etc. Another important ingredient here of impactful solution is that they may not be the most flashy. So also some different applications that can be early in research of development, or that can be really to optimize some things in the backends and etc. So the most sexy AI applications, such as flying car, autonomous vehicle, may actually not be the one to consider here. And AI is interestingly neither good nor bad in this aspect. For climate, there can also be negative applications of AI, for example, for extractive industries. So that's a little bit the context, and then comes all the different consideration about deployment. So simple methods can work, and in many cases, actually AI hasn't been used for a specific question. And the first thing to do usually is to start benchmarking this question with simple methods, and gradually build one's understanding of how this specific problem works, and whether it actually requires some more fancy deep learning or more complex methods. Then actually efficiency is great and it's very important, but it's not necessarily leading to an actual reduction of CO2 emissions and energy use if sometime efficiency leads to rebound effect. So this is a case where, because you have more efficiency, you will decide to actually use a service more because it costs less, for example. So that's where also it's important not to look at the marginal application itself, but how does it fit in the broader context. Equity questions here, like who are going to be the people who are going to get access to different technologies and different solutions, are also a key question, also related to where this is going to be implemented in the world. And something I'm going to keep repeating in the next slide is that partnerships are really key to deploy successful solutions. So researchers, industries, end users, policymakers, the different affected parties need to be put together around the same table to actually understand how deployment can research and deployment can lead to something that can work. So a few bottlenecks that we are seeing currently, and I want to acknowledge to understand how to move forward here, is that so there are currently knowledge bottlenecks. So essentially related to the understanding of what's impactful and not impactful around the different policy, industry, academic spheres, which because this is still an early topic, that's an early intersection that's currently developing, and that there's the real need that there's a broader understanding of what's currently impactful and what's currently not impactful in terms of the different techniques. And that's for example why we had the idea to start writing this paper. But this is still a work in progress to really understand what works and what doesn't work. Then there are still key bottlenecks around infrastructure, so data, funding, and policies to facilitate the development of impactful work from research all the way to development. And this is also something that is changing fast, and there is getting more and more interest from the different parties. But there's a need for more data, more funding, and more policies that facilitate research and development, and essentially to facilitate that, there's really a need of more cross-pollination across different the different actors that are involved, which are currently also still a bit too much in silos between industry, academia, policy, and whereas there's a need for more cross-pollination, because again, each of the different actors have something to some key information to bring to develop this solution that can work. So to finish, what can the industry do here? So essentially what industry does, right? So deploying impactful solutions. So turning on a proof of concept that may have been developed by academics to something, or that can also be developed directly by a startup or a bigger company, but that needs to be scaled up, because in order to actually achieve impactful solution, both on the adaptation side that will enable, for example, cities to become more resilient to climate impact, or that will enable to mitigate CO2 emission. We actually need solutions that go to scale, so that are really developed at large scale, and this is something that industry can do through the financial capital and the staff that industry can potentially raise more easily than academia. And another important aspect here is also the knowledge of the challenge that are related to building actual deploy system, as opposed to the small proof of concept. So that's a big thing that industry can do. Another thing is to open data for critical questions, because as I just mentioned, data is still remaining like a key bottleneck and data is obviously critical for machine learning. So without good data on the topic, it's difficult to learn anything. So there's still a lot of very valuable data that is still locked in silos in the industry. And there's a key role here to play to enable research, and it's not only one way by doing this. There are also great opportunities to so for example, when opening data to academics to collaborate and learn through these processes. Once again, like engaging with the relevant stakeholders in each stage of developing these different applications, so in scoping, in design, in development, to ensure to take into account all the relevant system that's connected to a specific application, and also sometimes to make sure to mitigate some excessive optimism around the potential of a specific technology, and to understand that sometimes it may take a little longer, or it can have some certain side effects that is important to take into account early on. So I just wanted to give a few words about Climate Change GIS, so the organization that I'm one organization that I'm working with, and that was created after with the core group of people that wrote this paper that I previously mentioned. And our goal here is really to try to catalyze impactful work at the intersection between climate change and AI. And so we are a global network of researchers, policymakers, and entrepreneurs, and we are trying to develop different resources, digital resources for people who want to work in this space. Also doing some advice in some events for knowledge sharing. So you can go on our website, climatechange.ai, and you can find the paper that I mentioned, where we have done interactive summaries to facilitate them, because it's quite a long paper. So this way you can skim through the topics that you are most interested in. We organized an array of various events at conferences and etc. that you can attend, and you can also see some recordings. And other type of event that we do is webinars. We actually have one that I'm hosting this Friday. So if you're interested in cities and urban planning, I invite you to join us on Friday noon. 11. No, so actually everybody is in Europe here, so it's in the afternoon, late afternoon in Europe. So it's 5 p.m. CEST, and some other webinars available online. And so if you want to engage further, we have a newsletter, we have a discussion forum, we are on the different social media. So feel free to engage, and looking forward to your questions.
Thank you very much, Nicolas, for presenting also your perspective on this topic. We have quite some minutes left for questions, which is nice. So again, the reminder to the audience, please post your questions on the chat. If you have any, then we will publish them and read them for you to answer them. If I may start with one question to Nicola, to your contribution, you mentioned various stakeholders, and I was a bit missing the dialogue from and with the financial industry. Besides politics, besides industry, besides civil society and academia, obviously, because this is where you have a lever to kind of shift flows, funding flows into the right direction. Now, is this, as I know Mercator Institute a little bit, but is this kind of what is at the core of Mercator as well, to have the stakeholder dialogue also with financial services, or something that has not popped up at your place so far?
No, this is also obviously becoming an increasingly important topic, as you said, because in the end, to finance this fast sustainability transition, we need capitals, and we need the different financial actors to understand also what are the key questions here, and provide them with also information to make better decisions and understand better risk, and etc. So this is definitely something where climate research in general has been putting more and more focus in the recent years, and that's not only related to AI applications, but also financial economics in general. And there are also AI applications here, where one key one from my perspective is really to provide more granular information, for example, for asset managers to understand actually what's the climate impact of their portfolio, and to be able to value to put value on the several climate risks that the assets may be facing, and also to put a value on the climate impact that their assets are generating through the CO2 emissions or energy use that are linked to these assets.
Eugene, you told us that you moved from the tech industry into the climate industry. And I mean, when I'm talking to especially young people, they are all interested in blockchain or in e-commerce or in AI in general. But what I don't see is, I mean, they all know climate change is real and we have to solve this issue. And I think they all are for climate tech. But I don't see that climate tech is sexy like, let's say, e-commerce or the fintech industry or any other industry. Can you say why? And do you have an idea how to change this, how to make climate tech sexy?
Mm-hmm. Yeah, that's a really good question. That's one that I keep thinking about a lot. I agree that it hasn't yet gotten to the point of being sexy. I think partially this is because the sexy stuff is largely, consumer-facing apps that, like, if everybody uses Google, so they think that Google is a really important thing. But I actually recently saw a pretty shocking number. Like, apparently, like, Google plus Facebook have something like 80% of all machine learning PhDs. I think that's bullshit. Like, it shouldn't be this way. Like, it shouldn't be perceived as this sexy. So as for how to solve this, I'm hoping that this will partially get solved as people understand more about what actually is climate tech. Like, I think, Tesla is pretty sexy. It is climate tech. I think more companies like that are going to appear, but they also definitely need to market themselves more as climate solutions companies. So most of the companies that I see are working in climate tech. Like, you can't find them by searching on LinkedIn for the word climate. They don't even mention it. They say, like, we're a building retrofitting company, like we're an energy efficiency company. We're like an alternative materials company. We're a sustainable finance company. And unless you already know how the climate space is structured, you're not going to find them, even if you're looking for your place in climate. So yeah, I think like they need to understand that the people who want to work for them are looking for a place in climate rather than a place in building retrofitting.
Yeah.
I think that could help. I mean, obviously, highlighting climate more at conferences helps. At least I hope so. That's why we're having this conference here. I think it's important for climate companies to start coming to job fairs at universities. From what I've heard from talking to students at various universities, they say that like climate companies are absent there. Partially that's because they're early stage and maybe like don't have the resources to go around everywhere, but maybe they have the resources to go somewhere. And I know that enough universities are willing to take them.
Yeah.
I can confirm maybe from that slide your picture that you showed at the beginning, Eugene, with the different tech players, and then kind of you having climate in everywhere, but then you're having a separate climate segment as well. This week in Paris, it starts VivaTech, which is one of the largest tech fairs in Europe, basically. We will be present there as well, part of the Swiss delegation. And I was looking around who else is there in climate. And I really can confirm straight to the point what you said now. There's so many e-commerce, so many other startup companies that somehow, all of them have a technological background, but once you search for climate and energy related companies, then it's getting quite thin. But same way as I see that this is improving, because looking at the earlier VivaTech conferences, you can really see this uplift. So I think this starts to grow now. Yeah, as same wise as maybe 7 years ago, AI companies started to grow, and AI is similar, right? They are dedicated AI companies, and then there is kind of AI technology that supports certain existing business models. So structurally, it's a bit the same concept. And we saw also this huge uplift 7, 8 years ago in AI. So I expect the same coming now as well.
I also think that's something that the machine learning community could do to like lift climate tech within the machine learning community is, do something on Kaggle. Like I tried finding some competitions related to the climate related AI problems on Kaggle. Last time I checked, there was nothing at all. And partially this is because there's also a data problem. I think Nicola can probably comment more on that actually.
Yeah, this is actually something we're trying to push forward, and it takes time because obviously you need to come up with this nice benchmarks and provide a nice problem that can be solved here. But there's actually something Change GIS is trying to push for, and we'll hopefully have some. We are really hoping that this is something that can also drive innovation and awareness in the machine learning sphere, given how important this challenge are to drive innovation on the machine learning front. But I agree, it's a key.
Because I mean, this idea of having a Kaggle competition is a very interesting one. Maybe we do it for the next year's conference and let the winners present at the conference. And I mean, what I understand is that data might be an issue here that for such a competition. But maybe we had the presentation by European Space Agency, and I think using the network of so many companies presenting at the Predictive Analytics World for Business for Industry 4.0 conferences, maybe we could leverage those connections to get data for such a competition.
Yeah, there are probably some problems for which it is easier to get data. Satellite data is probably easier to get than, for example, data on like the portfolios of different banks and their performance.
Yeah. So let's discuss this maybe on a follow-up call. Unfortunately, we are running out of time, and Christian, we should do some wrap-up. So Eugene and Nicola, thank you very much for your keynote presentations. Thanks for joining us, and looking forward to the next year's Predictive Analytics World Conferences for Climate.
Awesome. Yeah, thank you so much.
Thanks a lot.